Hi, this session is on replacement problem. It is part 2, as we have discussed in part 1. Model 1 for items whose running cost increases with time and value of money remains constant during the period. In this session also, the questions will be from the same model, but the questions will be from uh, different sort of information, right? So a variety of questions we try to uh, bring it in. We'll start with a practical problem which talks about XYZ manufacturing company is using a machine whose purchase price is 65,000. The installation charges amount to rupees 18,000 and the machine has a scrap value of only 8,000 because of because the firm has a monopoly of this type of work, right? The maintenance cost in various years is given in the following table, right? So a table is being framed which talks about years from 1 to 9 and maintenance cost is corresponding to each year, that is from first year to ninth year. Now, uh, let us first try to check it out whether the problem belongs to model 1 category or not. See, our maintenance cost is also named as annual cost, is also named as operating cost. And since it is in increasing order with year, so the first condition means items whose running cost increases with time. Secondly, there is no information about the discounting rate of money. Therefore, value of money remains constant. So the problem belongs to model 1 category. Now in model 1 category, to start with, we need to know about three different types of cost. To start with, we have given maintenance cost. We know maintenance cost is denoted by F, as it is same as annual cost, annual running cost or operating cost. Secondly, we require machine cost or cost of machine, which should be denoted as capital C. So uh, it is C. Now let us try to figure out our cost of machine. See, XYZ manufacturing company is using a machine whose purchase price is 65,000. The installation charges amount to 18,000. That means the total cost is 65,000 plus 18,000. So it is 65,000 plus 18,000 equals to 83,000. Now, these this cost and this installation charge, right? Both are constant irrespective of year. So for all the years, the cost will remain same. Next. The third cost we require is either scrap value or salvage value or resale value. So in our problem, it is given as and the machine has a scrap value. So scrap value. And scrap value is denoted as S. So it is 8,000 and again it is for all the years, right? How we concluded it is for all the years because it is mentioned over here. If it is not for all the years, then it should have been given in every year format, right? So next we have to go for depreciation, which is C minus S. So C minus S is this. This is your C, this is your S. So C minus S. C minus S. So I'm dragging it down. Now this is our depreciation. Next, we need to get cumulative operating cost that is sigma f. So sigma f, right? I'll wrap text. Fine. So cumulative is for the first maintenance cost. I should write it as cumulative for first. It is 12,000 of 1,250. I should write it as cumulative maintenance cost, right? Because in the problem it is given as maintenance cost and not the operating cost. For second, we know we have to get the total of this. So this plus this. Similarly, for third year, we know we need to get the total of these three. So this plus this. So likewise, I've just dragged it. Now I've got depreciation value, I have got cumulative maintenance cost. So therefore, I can draw total cost TC equals to depreciation plus sigma f, right? So it is depreciation plus sigma f. So total cost is depreciation plus sigma f. Depreciation plus sigma f. So let me drag it down. So this is our total cost. So finally, let us calculate average cost. AC equals to PC divided by small n, where small n equals to number of years. So total cost divided by number of years. Total cost divided by number of years, and let us drag down. So this is our average cost. Now look for the least average cost. Average cost, see, 19,583.33 is the least average cost, right? So I just highlight it, and the year corresponding to this is 6th. So I highlighted this. That means the machine should be replaced in the 6th year as this year has least average cost, right? Let us try to see another problem of a little different uh, category. Category in the sense it will belong to model 1, but the informations will be given a little different way. So see, the data collected in running a machine, the cost of which is rupees 60,000 are given below. Here for 5 years data has been given. It is the resale value. So we know resale, it is denoted as capital S. Now see, nowhere it has been mentioned the operating cost, the running cost or maintenance cost. But two new costs have been given, that is cost of spares and cost of labors. Now, try to reach to a situation that a machine requires spares and labors to run the show, right? That is why instead of maintenance or running cost, the two categories of running cost has been given, right? So these are the two categories. If we add it up, we will reach to our running cost. Fine. So our running, or I'm writing as operating cost. Operating cost, we write it as F. So operating cost, how to get our operating cost? Add these two factors. So this is our operating cost. this plus this, and let me drag it. So this is our operating cost. So we have got our resale value, we have our operating cost. The third which we require is cost of machine. This is capital C, right? So this is our cost of machine, and it is given that cost of machine is 60,000. Fine. Let us calculate depreciation equals to C minus S. So what is our C? Cost minus C resale value is here. Again, this is our cost minus this is our resale value, right? So bring it down. Now this is our depreciation. Next, let us go for cumulative operating cost, which is our symbols sigma and F, correct? So this is our operating cost. That means for first it will remain same. Second one, it is the summation of these two. So this plus this. Third, it is summation of these three. So this plus this. And likewise I drag down. Then we need to have total cost. TC equals to depreciation plus sigma F, right? So sigma F. Fine. So total cost is depreciation plus sigma F, depreciation plus sigma F. Let me drag it. So this is the total cost. Finally, we need to have our average cost. AC equals to PC by N. So this is our total cost divided by number of years. This is our total cost divided by number of years. Let me drag it down. Now finally we have our average cost column. So let us look for the least value in average cost. There is 36,000, 34,000, 33,716, 33,362. This is the least value. We highlight this and let us go to the year for which it is the least. It is 4th year. That means the machine should be replaced. The machine should be replaced in the 4th year as the average cost is least. Hope you have understood. For any further query, you can mail me on arg.srkr86@gmail.com. Thank you.